Hello, in this video we'll go through section 8 review, and what we're going to see a lot as we go through this, we're going to keep coming back to, are you a formula person or are you a concept person? So I'll keep saying that. We're not going to do each problem several times, but a lot of them will get done a couple of times, so a lot of you can start to figure out what makes more sense for you. The directions here, I just wrote perform the following operations, simplify your answer, and we've got these 8 problems. So again, if you want to try and do them on your own, make sure you start. Okay, now as we go through, before I jump in, just 2 little points. First thing, I just said perform the following operations. We should be able to look at problems and be able to just see that's multiplication, that's division, this has powers to a power. So little things like that just to make sure we're identifying. But the bigger thing in the directions is that it always just has this simplify. And this idea of simplify, sometimes our book really goes to extra extents to explain that, but other times it just simply says simplify. So when it says that, we have to understand what they're looking for. And there's basically 2 main things. Every time we look to simplify, we have no negative exponents. That's a huge part. That if we have a negative exponent like that there's an aspect of simplification that we are expected to do. So that's a big one. The second thing, and some people kind of write these as 2 or 3 things, but a second thing would be no zero exponents either. We know we have a specific rule for that, so we won't leave something to a 0 power. We'll make sure we continue going forward with that. And the last thing, we shouldn't have multiple of the same variable. That if I have x's and x's, whether they're being multiplied or divided, that in some way, shape, or form, we should only have one x at the end. We shouldn't have x's on top or in the bottom or in the left and on the right. That in some way, we should be combining, canceling to just have one x after the fact. So that's our directions. So now as we actually start to jump in, we look at problem number 1, and we realize this is purely about simplifying. Yeah, you might be able to say x and y are being multiplied, but as far as our rules are concerned, it's got to be the same base. X to a power times x to a power, y to a power times y to a power. So this one, there's no operation, it's purely about the simplification. And like we were saying up above, this idea of no negative exponents, well, this has a negative exponent. So remembering our rule, and this again, are you a rule person or a concept? Concept people, negative exponents just change their place in the fraction and they become positive. Rule people, they've got a rule x to the negative n equals 1 over x to the positive n. That's the rule that they are using. So that's one aspect. That y is going to go into the denominator and become y to the positive 7. What about the x? Well, that's where we have the 0 exponent. And once again, as a rule, we know something to the 0 power is 1. And that's all we'll do here. We definitely still need to show that 1. There has to be something left in the numerator to clearly separate numerator and denominator. I move to problem number 2. And again, at a quick glance, it looks like there's multiplication and division here, but there's nothing of the same variable. So there's no multiplying a's into b's or dividing b's into c's. This is once again more about my simplification. And as I go through, well, there's nothing else to do with a. There's no other a's that are being multiplied or divided. So that a is fine. That stays a to the 4th exactly where it is. But then for the b, the negative exponent, just like we saw over here, that negative exponent is something I'm expected to simplify, and that's supposed to be make it into a positive exponent, and it goes to the denominator in order to do that. But then c is in the denominator. It is already in the bottom, and it has that negative exponent. That's where, again, some people, the formula, now they've got another 1 over this over 1 over c to the 10th, and they get a mess. That's where some of us, again, the concept is easier. A negative exponent changes its spot. Well, this was in the top, it went to the bottom. This was in the bottom, now it's going to go to the top. My c will now go in the top, and it'll now be c to the positive 10 in the top. A to the 4th, c to the 10th, divided by b cubed is my final answer. Now I come to number 3, and now for the first time I have some real operation. I am multiplying this expression times this one. How do I actually go through and do that? This is a big reminder, there's no distribution here. It's not -6 times -3, and -6 times x, and -6 times y. That's not it. Remember, the idea of distribution, let me come down here to just point that out. The idea of distribution would be something like this, distributing the 2x across that addition or subtraction. That's where we get true distribution. And even if we do distribute something like this is where we still do what's nice. Technically, there's a 1 in front here. I do 2 times 1 gives me 2, and then I multiply my x's and I get x to the 4. Over here, now I do the 2 times 4 is the 8, and the x is still just there. So that's the idea of distribution. That's not what we're seeing here. This is just regular multiplication. And when we did this in the whole introduction video, we showed you could change the order to put the nice stuff with the nice stuff. But what it really boils down to, put the stuff that goes together. You're multiplying, but what multiplies? Multiply the -6 times the -3. And that gives me a positive 18. Multiply the x's times the x's. Well, this is an x to the 4. This is an x. It seems like I need to know that exponent. It's not there. We can assume that's a 1. Just an x by itself is an x to the 1st power. And now, once again, are you a concept person or are you a formula person? A formula person here, they're looking at x to the n times x to the m is x to the n plus m. That's what we see by our formula. X to the 4 times x to the 1 becomes x to the 4 plus 1 will give me x to the 5th. But the concept, I'm grouping all these x's together. I've already got 4 x's being multiplied together, and now I get another 1x being multiplied by those, gives me a total of 5 x's. And the exact same thing with the y's. Y to the 12th times y to the 7th. Formula people, I wrote the formula in terms of x, but it's just about having the same variable. It's a very important part. If you didn't get that in the instructional video, some people just copy the formulas, but other people, this is a great spot to remember. Fill in your own words. What is that formula actually telling you? And it's not just variable x, it's about having the same variable base. So y's times y's, I follow this formula, and 12 plus 7 would give me a new exponent of 19, y to the 19 power. Or the concept people, I've got 12 y's being multiplied, and I got 7 y's being multiplied. Group that together gives me 19 y's that are being multiplied. So you see, formula or concept, when the exponents tend to be more friendly, it just lines up very nicely all together. When the exponents, when we start getting some negatives and things like that, that's where it can be a little extra challenging. But hopefully so far you're feeling comfortable in figuring out what works for you. The last thing before I go to the next one, just to also realize you're once again mixing regular arithmetic with these exponential rules. So we're adding the exponents here, and then it just becomes such a common mistake that people start adding the numbers in front. But no, that was regular multiplication, and we are multiplying here. It's just the rule says add the exponents. Similar number 4. Now I'm dividing. My division rule, this is where we saw there's so many little tweaks to it. I'm going to keep it simple. If you're a rule person, you're looking at x to the n divided by x to the m is x to the n minus m power. But that's where we said there's so many particulars. If you want to follow the formula in its most basic rule, your final variable always ends up upstairs, and you always do top exponent minus bottom exponent. But other people, the concept people, this is about canceling the common variables from top and bottom. So two different ways to look at it, but when we actually get into the problem, I'm still doing the same thing like we did here. It's all of this divided by all of this, but I'm not doing 28 divided by 7, and then 28 divided by x squared, 28 divided by y to the 9th. Again, the little differences, that's real distribution. And as we've gone through all the work with our straight lines, we have seen places where you have to divide multiple pieces, but again, it's about having addition, subtraction. Go back to something in a straight line situation, 2y equals 6x minus 8. Finish solving for y, you're dividing both sides by 2. Cancels here, gives me my y. Over here, that's the situation. Again, it's the addition, subtraction between the terms caused me to multiply across both terms. The subtraction here forces me to divide both terms separately. That's not what we're seeing here. This one, you would do 6 divided by 2 is 3, and the x comes down, minus 8 divided by 2 is 4, and we'd finish here. But in this one, keep them separate. 28 divided by 7, that gives me a clean 4. Rule people, I've got the common x's that I'm dividing. I follow my rules. I do top exponent minus bottom. I go 14 minus 2 is 12, so I get x to the 12th power. My y, same thing. Top exponent minus bottom. I get 9 minus 9 is 0. And this is where we got to say, okay, wait. Before I'm done, I did all the right arithmetic, but make sure before I just walk away to fully simplify. Here, everything was done. No negative exponents. Everything was nice and clean. We're finished. Here, we've got a 0 exponent. One more step. The y to the 0 becomes a times 1, and 4x to the 12th times 1 is just 4x to the 12th. Come back up here. If you're a concept person, it's about canceling. I've got 2 x's that cancel. Well, if I cancel 2 x's here, I've got 12 x's left, and those 12 x's are upstairs. Versus here, 9 y's that are being multiplied, they all cancel, and there's just simply no y's left. And sometimes, if you're a concept person, it might go a little bit faster, but it's not about being fast, it's about being right. Now I come to number 5, and now I see I've got a couple little possibilities. The biggest thing, well, I guess 2 things happening here. Number 1 is that just starting with my numbers, you know, we love having this situation, 28 divided by 7 is a clean 4, but 10 divided by 20, it's already a proper fraction. But we still want to reduce it, just like we saw with slopes. If I had a 10 over 20 in a straight line problem, I can make that work as a slope, but it's so much better to reduce it. In this case, canceling a 10 and being left with 1 over 2. That would be ideal. So that's one aspect. That I'm still dividing, and if I get clean division, that's great. But if I don't, I'd still love to reduce the numbers as best I can. But now coming over here, if you're a rule person, well, let's just be straightforward with the rules. You're subtracting, and you always leave the variable up top. So my x is on top, 5 minus a minus 6. If you're a rule person, you have to be ready with these negative exponents to just incorporate that to the formula. That becomes 5 minus a minus 6. That actually ends up becoming a plus. I'll end up with an x to the 11th power. Then my y's in a very similar way. It always goes top minus bottom. So that's just a 3 minus 7. I end up with a y to the negative 4. This one, the extra negative felt goofy, but actually led to addition. No problem with that. But then here, I did my straightforward subtraction, but I finished with a negative exponent. Have to clean that up. Just like here, we had a y to the 0, technically correct, but not simplified. Here we had a y to the negative 4. Let's simplify it. And at the end here, that 1 is technically still there, but because I have other stuff, what is 1 times x to the 11? You could certainly just leave that as x to the 11. All right, but let's go backwards. And I'm running a little short on space. Let me come down here for this. Let me rewrite the problem. We started off with 10x to the 5th y cubed over 20x to the negative 6 y to the 7. Some people right off the bat, especially if you're a concept person, negative exponents really mess with our concepts. When we're canceling, when we're combining, it just doesn't really make sense to combine something to a negative power. So as we've seen before, if you really want to think about the negative exponent, don't think about it as a negative, convert it back to a positive. So that this, the 10 is fine, the x to the 5th is fine, the y to the cube is fine, but down here, that x to the minus 6, I'm going to bring that up as x to the positive 6. The 20 is still downstairs, that y to the 7 is still downstairs. So now that little rewrite, and now my work is just a little bit different. I still have the 10 over 20. I'm still going to reduce that as a simple 1 over 2, canceling a common 10 top and bottom. But now my x's, I'm not actually dividing. I'm multiplying. These x's are right next to each other. They're being multiplied. They're being combined. I get my x to the 11. And now my y's, concepts, I'm canceling. But now I've got more y's downstairs than upstairs, so I'm canceling 3 y's here. I'm canceling 3 y's here, but that still leaves me 4 y's in the denominator. Look at that answer. 1x to the 11 over 2y to the 4th. No surprise, exactly the same thing we had back up here. So again, little bit here, just strictly followed rules, cleaned up a little at the end, was able to handle that double negative. Here, get rid of the negative. Follow your concepts, combining here, canceling here, and of course, we still get to the same spot. Now number 6, now I've got all this to a power. So this is where we do have a sense of distribution. That exponent does get distributed across to all pieces. But just notice here, the minus is a part of the 2. So it's not a minus out in front and then 2 to the 4th. The minus is attached to that 2. All that is being raised to the 4th. Then I've got an x to the 5 raised to the 4th power and a y to the negative 3 to the 4th power. Now, just like we've seen before, do each piece separately. We've got rules for the variables, but the regular number, that's just regular multiplication. And especially going through some of the take-homes, some of you are still goofing with this. It's very tempting to just go minus 2 times 4 is minus 8, but you're missing the concept of the exponent. It's minus 2 times itself 4 times. Minus 2 times minus 2 is positive 4, times another minus 2 is negative 8, times another minus 2 is positive 16. And then both of these, power to a power. Again, I'll squeeze it in up here. Another rule, x to the n to the m is x to the nm power. A power to a power, we multiply those exponents. So x to the 5 to the 4, that's where I'll multiply. And that's where, again, folks, it's tempting back here with division, with multiplication, to just stick with the rules and forget what's happening with the numbers. But this is the real major spot it happens. People go x to the 5 to the 4 is x to the 20, And it's just so tempting to just come right back here and go minus 2 times 4 is minus 8. But now we're finishing over here. Same thing. Just because this is a negative, the rule still says we just multiply. Negative 3 times 4 is negative 12. But now, am I done? I've done all the right work, but just the simplify part, I once again see a negative exponent. 16 stays where it is. X stays where it is. It's just the term with the negative exponent that moves. So even coming back here, some people have the mistake. It's like, well, what else moves? It's just the y. Here, once again, it's just the y. The 2 was downstairs before, it stays downstairs. The 16 is upstairs before, it stays upstairs. It's just the y that's moving. But this is another one that, just like we saw in number 5, some people just hate seeing that negative exponent. It really, really bugs them. So let's do it again, and let's deal with that negative exponent first. Negative 2x to the 5, y to the negative 3, all to the 4th. Some people, their first move, I hate the negative exponent, so get rid of it. Minus 2 stays where it is. X to the 5th stays where it is. Y to the negative 3, to the bottom as y cubed. Still have that exponent of 4. And now I'm still distributing the exponent. Doesn't matter if my terms are connected by multiplication or by division. That's where I can get away with just distributing the exponent. Minus 2 to the 4. There's my positive 16. X to the 5 to the 4. There's your x to the 20. Y cubed to the 4. There's your y to the 12th. We're right back where we were. So just one more time, you're starting to get the sense, how do you prefer to deal with negatives? Some people, I'll just know my rules, deal with them along the way, and at the end of the problem, I'll clean it up like we did here and like we did here. Other people, first thing, I hate the negative exponent, get rid of that right off the bat, and then I can solve. Either way gets you on the right path, and you'll get to a full correct solution. Last two, numbers 7 and 8. Now we've got some combinations. I've got multiplication, but I also have this extra exponent, a power to a power. Where do I start? Number 8, I've got division, but I also have all this raised to a power to a power. Where do I start? So this is where some people, it's all about PEMDAS. Here, PEMDAS, before I can do any multiplication, I've got to do my exponent. And that's a great way to start. In number 8, however, P, the PEMDAS, we've got internal parentheses work. So we definitely can start there, but I would point out, if you just distributed first, it would work, but you just have to clean up secondly, and your numbers get pretty big. So again, this is where some people get so obsessed, and it bothers some students because it feels like they have some choices, and they do. And that kind of can get annoying sometimes. Some students would rather just have a direct do this as their situation. But for this, it really is what you're more comfortable with. And I want to be honest, going forward, we're not going to get so many negative exponents. They come up here in section 8, but as we get deeper in this next big unit of the class, most of it is just the nice positive whole number exponents. But again, this section, they include it, so you definitely want to get used to it for problems in this section. There's almost certainly going to be at least one of them that comes up on our test that goes with this section. So, number 7, I'm starting with that exponent, distributing the exponent here, minus 3 squared, right? And actually, let me write it out. Let me not try and do too much in my head. Some people do get right to work here, but especially some others really got to make sure they're taking their time, that they're being meticulous. Otherwise, they're just asking for some mistakes. So I'll write it all out. And again, want to be clear, the negative is a part of what is being squared. It's not 3 times 3 is 9, and the negative hangs out. The negative is a part of what's being squared. A to the 4th squared, b to the 10th squared. Regular arithmetic here. gives me a positive 9. A to the 4 to the second, multiplying that gives me A to the 8. B to the 10 to the second, multiplying those gives me B to the 20th. This is still here, and we're once again going to see those choices. How do you deal with the negative exponent? Leaving it as is, I've got 5a to the negative 8b cubed. Now I'm multiplying, just like number 3, I'm multiplying the nice stuff with the nice stuff. I'm doing 9 times 5, gives me a clean 45. My a's, if I'm a rule person, I'm getting a to the 8 plus a negative 8. Just like we saw up here, that negative has to be incorporated into the formula. So here it was minus a minus, actually became a plus. Here it's plus a minus, it actually just becomes a minus. So I will get a to the 0 when I put that together. And then my b's, b to the 20 times b cubed. Well, that's a nicer one. 20 plus 3 is 23. Am I done? Mostly, but still always just coming back, thinking about that simplify back to a 0. A negative exponent has to be moved. A 0 exponent, that whole thing becomes times 1. It's not a to the first power, it's the whole thing becomes 1 so that there's no more a's, and 45 times 1 is, of course, just 45. So 45b to the 23rd. But one more time, little alternative. This part goes exactly the same way. Nothing changes there. So let me even change color here. So I got my 9a to the 8th, b to the 20. But on this side, I've got 5. That a to the negative 8 goes to the denominator, a to the positive 8, b cubed. And it looks like we're multiplying, and we mostly are, but it's mostly about keeping track of top and bottom. The 9 and the 5 are both on top. When you multiply, right, top times top, bottom times bottom, they're both on top. 9 times 5 gives me the 45. The b's, they're both on top. Those are being multiplied. B to the 20th times b cubed gives me 23 b's being multiplied. And then my a's, well, that's on top, that's on the bottom. This is actually division. And now, well, if you're a rule person, it becomes a more straightforward a to the 8 minus 8, nothing too fancy with any extra negatives, and that'll become a to the 0. So we're right back where we were here. The a to the 0, you'd replace with a 1. If you're a concept person, they just perfectly cancel. All the a's cancel. There's no a's left. 45b to the 23rd. Last problem. Again, this is where you can get lucky. The rule would allow you to just square everything on top, square everything on the bottom, but all of a sudden your numbers are getting very big. Let's make this easy. Let's clean up the inside. Right off the bat, I've got 15 divided by negative 5. Just separate this a little bit. 15 divided by negative 5, that is negative 3. I've got x to the first divided by x to the fourth, right? It's an x, so I have to realize that's x to the first power. So x to the first times x to the fourth. X to the first divided by x to the fourth. Rule people, x to the 1 minus 4, you get x to the negative 3. Concept people, 1x cancels from 1x here, leaves 3 x's in the denominator. Y's, follow the rule. 7 minus 2 gives me a 5, very clean. If I'm a concept person, these y's all cancel. Cancel 2 y's from the top, leaves me with 5 y's in the top. All of this is still being squared, and now I'll distribute that exponent. Minus 3 squared Just running a little short on room, but we did that exact same thing here. That's a positive 9. Y to the 5th squared. Y to the 5th squared becomes y to the 5 times 2, y to the 10th. X cubed squared, x to the 3 times 2, x to the 6. 9y to the 10 over x to the 6th. Just one little thing I'm going to squeeze back in here. Just back here, I said it quickly. If you're a straightforward rule person, we got the minus 3 here. We got an x to the minus 3 here. Y to the 5th here. Still squaring. You get your positive 9. Here you get an x to the negative 6. You get x to the negative 3 squared. Negative 3 times 2 gives you negative 6. Y to the 10th. But then you just have that little bit of cleanup at the end. That x to the negative 6 put into the denominator to make it a positive. And that is your final answer.